Hello. That's a lot of people, and I'm a bit nervous. So if I'm looking at somebody, you just nod along, so I feel more confident. Okay, so the actual talk, the actual title of my talk is From Buildings to Software, Paving the Way to Construction. The one on your program is the old title, which I changed to be more specific. So, a few words about myself. I'm an architectural engineer by training, and currently I work as a front-end developer at Upstream, which is a leading mobile commerce company in Greece. And before that, I used to work as a web developer at the National Center for Scientific Research, Mockups in Greece, where I had my first encounter with Angular and professional web development, which was the summer of 2015, so obviously it was Angular 1. So how did that come about? I was given a project to work on, a sort of a website, and I was the only dedicated front-end developer for that website, and I had to choose my tools. It had to have a live feed, it had to have user comments, so I chose Angular. Why did I choose Angular? Because a colleague had mentioned it. It was Google, and I knew that it had a strong community. And 3, I tried the phone catalog tutorial in the AngularJS website. I believe some of you know that. And I really liked it because it reminded me a lot of principles that we were taught in architecture school. I'm going to explain how. So I live in Athens, Greece, with my cats. So yeah. So basically, today this is going to be a not-so-technical talk. I'm going to ease you in the conference with the not-so-technical talk. Basically, I'm going to make an analogy between how building a building is similar to building a software. So first, we're going to have a crash course on architecture and how you're laying out a building. And then we're going to talk about how you could lay out your web application step by step in a similar way. Then we're going to do a recap, and then I'm going to talk to you about the reasons why I think this is helpful. So, my initial thought for a title was building software. It was sort of like a play on words. Like you have 2 nouns where actually somebody would think that it's a verb and a noun. So it's a building and some software. And to make the analogy. So basically, the talk is how designing buildings help me design and, well, build software, steady software with a robust base, with a well-defined structure, and the variety of structural elements. I believe you're seeing where I'm getting at. So yeah, when you're in architecture school, you are given a task every year. So, for example, say that the task is to make a community center. So the community center has some parameters. Such parameters are that the community center has to have specific activities, for example. It should have a theater, a library, a cafe. It should be no more than 500 square meters, because this is the area you have available. It should follow some local municipality guidelines, so accessibility, appearance, branding. And you have to think of the end users, which are the residents of a quiet family neighborhood, for example. So you have your problem, your task, and you have your parameters. So you do your research, you analyze your parameters, you see the legislations, the guidelines, and you grab your pen and paper and you start drawing. So first of all, you do the sketches. So some initial sketches would be about how you want your users, your people, to navigate through the building, the user flow, where to go. You start drawing some shapes. You start drawing and adding shapes and lines until your building has sort of a final form. Once you know how your form is going to be, you can start making some plans. First, you plan on a large scale, so that you know where each space goes, how much space each individual room takes. So you have your larger scale plan. And then you can move on finer scales and start adding elements, structural elements, the components. Like you see here, we have tiles, you have furniture, stairs. So then you can go into more detailed blueprints, where you can add even more elements and components in the whole building. So you can add chairs, Or you can even see how a wall is built with insulation, with bricks, or with concrete. And you can go in a so fine scale that you can even design the shades or the glazing. So, how is that similar to designing a web application? So, it's step by step. You recognize the needs of your user, you set down the plans, you start scaffolding, you define your components, your structural elements, and you create some mock screens, and you start coding. So, I'm going to make an analogy here. It's a web house. This is a joke. I'm just making this clear. So yeah, say that you have a house, and if this house were a web page, it's a joke again, it would have a root tag, which would be the building. It would have some beams as components. It would have some columns, other components. It would have a wall. And inside the wall, it would have insulation and brick, a stack of bricks. OK, I'm glad you're laughing, because I was thinking of adding canned laughs sometimes like this, when nobody laughs. OK, you have your roof, the attic window, the door. The window has a frame, glazing, handle, apron. So you can see that everything has more components and more elements inside. And you have the chimney, and it's a joke again. OK. So let's see how the process of laying out step-by-step a web application would be. So say, for example, that I want to make a web application that is my digital portfolio. What would be the requirements? I would want it to have a list of my projects. I would want to be able to add a new project, to edit an existing project, delete any embarrassing ones from my first year in college. And any user should be able to view details for each project. It should be user-friendly to attract my future employers. And it should be available on the web, on the mobile web. So this is my problem task again. These are the parameters. So what do? I start drawing. So first, again, you want to see, you want to see how your users are going to navigate through your app. So you create a navigation tree. So you would have the root of your application, and you would have some separate screens. For this application, I would want to have a home screen, and about screen, and a contact screen on the same level. And then, for example, I would have the project details. Then I would have the application root, the bearing structure, which would have some components that would be the same throughout the whole application, which would be the header, the menu, the content container, which is going to contain all the pages inside it, and the footer. Then I have the front page, which has the header, the menu, the content container, and the footer. And inside the content container, I would have a list of projects. Then the about page would have a header, menu, content container, footer, text, and a photo. And the contacts page would have the header, menu, content container, footer, and a contact form, a map, and social media buttons. So you see that from the initial drafting, you can initially start seeing that how your structure of your application is going to be. We just drawing some sketches. So now we can see some mockups. The disclaimer is that it's not a user interface, user experience design presentation, so don't judge. All elements are from the material design sticker sheet. So at this stage, your mockups are your large-scale plans. So you just have some rough mockup screens are put together. Initially, they can just be a layout of elements, so I draft to make sure nothing is left out. And it's in large scale, there's no need for details or any fine-tuning. You just need to see that everything will go wherever you want to go. So you would have your front page. And a new component would be a list item and an add button. You have this is my cat again. The about page would have the header, of course, and the menu, and would have the text and the photo. The contacts page would have an editable element, which is going to repeat itself in the form. It would have the map, and you would have social media buttons. The details page, again, it would have a carousel, edit buttons, which are going to repeat themselves, and the new project page, which we forgot before, has again the Add button from the front page, the Edit button from the previous page, the button, and the editable elements. So again, you're seeing more components come up, and you just note them down, and you know how and where to put them. So what do we learn from this stage? From this stage, from the draft mockup screens, they reveal elements that we never thought were there, or we didn't think of them before, so that we can plan our code and the procedure of making our code better. This can keep us prepared and informed about what to expect, so to make a better plan. And sometimes they reveal the need for a UI UX designer. So just as you wouldn't go about building a house without the plans, or the architects. Yeah. So, yeah, I have to tell you, I scrolled really far down to find a woman builder that didn't look strange. So, yeah. OK. So at this stage, you move into the finer detail mock screens, the live demos, etc., which I'm not going to. It's just this is just some general idea. I'm not going to go deeper into details for this, but it's similar to the more detailed, finer scale plans. So yeah, after you have this, you start implementing the plan. So again, this is a screen of AutoCAD. This is a computer-aided design, and the other one is the Atom, just another analogy here. So the recap. So again, the similar way is that you start with drawing a draft of your navigation tree, then drawing the drafts of your screens, then drawing some large-scale mockups which don't have details, then finer details, then you start coding, and then you have, this is a my Twitter screenshot, you have your website. So why is this important, and why am I here today? Why am I sharing this with you? What is it good for? In my previous job, I had a colleague, Manolis, who was, he had studied architectural engineering. He's 10 years my senior, and he had moved from architectural engineering to software engineering. Now he's writing C++ somewhere. And he used to always tell me, he was like my mentor, my personal Yoda, he always used to tell me that the programmer has to grab a pen and paper, and the planner has to write some code. About the second part, I'm not sure why he told it, but about the first part, what he meant, I think, is that you have to actually grab your pen and paper, you have to start lay out your whole plan, and you have to have a whole image of what you're going to do in order to be prepared and know exactly how to do it and what to expect. And you never really know the full scale until you have planned it before. So what is helpful in this approach is that you plan your work in detail. The planning makes the task easier, because if you have a big problem and you break it into small parts, it becomes more manageable. It helps you, of course, have better estimates for how long anything is going to take. It prevents you from unanticipated issues, like creating some bunch of code that should be broken up or should be together. And your code is more scalable. It's easier to maintain, easier to change. You can more easily add new things. So Angular gives you the tools for that. So why not use them? You have your components, you have your templates, you have your routers. So they're there to help you do just that. So if you type into Wikipedia software build, it says in the field of software development, the term build is similar to that of any other field. That is the construction of something that has an observable and tangible result. So obviously, I began with architectural engineering studying it, and I found transition into web development, because I really never liked architectural engineering, that there were skills that I had gotten from this that really do cross over, and some building and design techniques do help you. So building design is a very old discipline, and the process of designing a building is very similar to that of designing an application, in the sense that you need drafts, You need detailed plans, you need structural elements, and a full fine-scale blueprint. And this process has been tested for thousands of years. I mean, they had this, the building design discipline is so old. So why not use these techniques in software development too? And I know most of you do, but just for those who don't, you just do it. So these are the components that Angular gives you, the structural elements. So you wouldn't build your home without planning out first, so I do it with your homepage. So just remember, it's not necessary to build software that actually looks like a building or a group of buildings. Who gets this reference? Is there anybody here who gets this? Yes. So it's Jurassic Park. So in Jurassic Park, the velociraptors are chasing the family, and the family is hidden in this building, is in this room where all the software thing was going on. And the girl has to run a script that will lock all the doors and lock the velociraptors out. So she goes onto the computer screen. She sees the computer screen and she says, wow, this is Unix, I know this. And yeah, it's not Unix exactly. And there's actually a 3D file system navigator from Silicon Graphics. And she just goes there and she tries to navigate through the buildings that the buildings are the files. And it's very funny because it's very difficult to navigate through the buildings. So she does, she finds the file at the last moment, yeah, but this is not a good example because she actually almost fails. Yeah. So that was the presentation. Thank you.